Data builds up every day. We have now more data than what we had yesterday. That means data is being complex day by day. True data generation is important because faulty data and data measurement methods would render the entire improvement process planning and decisions to a wrong direction. Measurement system analysis is to evaluate the capacity of the measurement system, which may be via the gauges or instruments or some procedures with the help of analytical tools like accuracy, precision, linearity, repeatability, reproducibility, stability, and bias, etc. The reliability of the measurement system depends on whether our measurement system is sound enough to address variation. Measurement system analysis, or MSA, is an experimental and mathematical method of analyzing and determining the level of variation within the measurement process that contributes to overall process variability. Now, let us see some sources of variation of the data. There could be different sources that produces variation of the data. It could be process, for example, test methods and specification. It could be personal, which involves the operators. If low-trained operators are measuring anything, chances are that they may cause error and there could be variation of the data. The sources of variation could also be the tools and equipments, gauges, fixtures, test equipments used, and their associated calibrated systems could be involved for this. Variation could also be because of the items to be measured, the part of material sampled measure. It could also be because of the sampling plan. And there could be environmental factors such as temperature and humidity as a source of variation. Most measurement system analysis activities examine two primary sources of variation: the parts and measurement of those parts. Part-to-part variation. It is the variability in the measurement across different parts. Measurement system variation are the variation associated with the measurement process. Here we study two types of measurement system variation. The first is repeatability, which is variation in measurement due to measuring device. It is the variation observed when the same operator measures the same part, or the part is usually the things getting measured, repeatedly with the same device. So, when a same operator measures the same part repeatedly with the same device, and also if there is variation, we call that repeatability. Reproducibility is the variation due to the operators and the interaction between operator and part or what he or she is measuring. The sum of these two variations, that is, sum of variation due to true process variation and variation due to measurement system, represents the total observed variation in a measurement system. See this picture here. The sum of the squares of repeatability and reproducibility is giving us the measurement system variation, which is also called total Gage R and R. And the sum of squares of part-to-part variation and measurement system variation, as we already discussed, gives us total variation. With this, we have come to the end of the lecture. But before finishing, let us head to the usual section. Let's run the quiz. Manjit measures the internal diameter of a water supply PVC pipe and records the following observation when he repeatedly measures the pipe through a vernier caliper or say the measuring device. The true value of the internal diameter, suppose, is 3.112 cm. The reading is shown here. So it seems like there is variation in the internal diameter of the pipe. So what kind of variation does this point us? Is it variation due to repeatability or is it due to reproducibility? Okay, let me reveal the answer. This time the answer is repeatability, because Manjit is measuring same pipe or say same part repeatedly with the same measuring instrument and still he is observing different measurements. So this is repeatability. Second scenario. Manjit, Sujit, Mark, Paul and Raman recorded their measurement of the same internal diameter of the pipe and observed the following readings, and they recorded that there is variation from the true value of the pipe. What kind of variation is this? Is this variation due to repeatability or reproducibility? This is quite an easy one. We know that reproducibility is the variation due to the operators and the interaction between operator and the part or what he or she is measuring. Here there is variation between operators or people who are measuring same part. So it has to go with reproducibility. Thank you so much for staying with me so far. There are many other simulated case studies and practical learnings in this course ahead. Let's move on.